This is the second video in the series for the class examples 3.4. We're on the second tab, on the rate of change tab this time, and it's a little bit different situation. This time we've got an equation already given to us, an h of t for the height of the golf ball. So a golf ball's been hit, and the height above the ground will be determined by this equation for the first 15 seconds the golf ball after the golf ball is hit. So we've put that data in over here, looking at the first 15 seconds and the height. Notice that the height was calculated using that equation that we were given with the h of t. And we have the graph of the golf ball, which is the expected picture of what we would expect a golf ball to do after being hit. And what we want to do is look at average rate of change and instantaneous rate of change. An average rate of change would be what you would expect. We've actually already calculated that in this third column, which you can double click in and see the y2 minus y1 over x2 minus x1. Do it down here between 8 and 7 seconds, or maybe between the 11 and 12 seconds. And we can see what we were expecting, that we've got some positive values so that the height is increasing between each second. Here it's decreasing, so we can tell when the height is falling, when the ball is falling. And so we could do, you could even do the height between, or the average rate of change between 3 and 8 seconds. We could calculate that. Doing the same calculation we did before, so y2 minus y1 divided by x2 minus x1, and talk about the way that the height of the ball is changing between 3 and 8 seconds. And we could do that with any pair of seconds that we have over here. But what we want to look at is, just like the last thing that we were doing on the skid marks and the speed question, is to look at what would happen when the golf ball is exactly at 4 seconds. Let's pretend that the golf ball goes up and at 4 seconds it hits a tree limb and drops straight down. So that it doesn't continue the path all the way that it was anticipated to do. It's going to stop right at 4 seconds. And we might be curious at how fast it was traveling at exactly 4 seconds. To do that, we're going to create a table very similar to what we did with the skid marks and set up these, answer all of these questions. Well, what was the average rate of change between 4 and 4.5 seconds? What about 4 and 4.1 seconds? Notice that we just got closer to 4 with that pairing. And 4 seconds and 4.01, now we're closer to 4. And 4 and 4.001, which is again closer to 4. So let's set up the table. 4.1, 4.01, 4.001. And I'll just make all of those centered to make them look the same. And then we'll put, noticing that the equation is already in the cell C16, we can just drag that down. We don't have to retype that function. So I can tell where the ball is at any of these seconds in time. Now to find the average rate of change, the first one says between 4 and 4.5. So we'll do the same thing we were doing before. y2 minus y1, x2 minus x1. So why don't you stop the video and make sure that you can get these calculations done that we've done so far. Try out a few of the average rate of changes that are over here in the table. Make sure you can practice those again, just like that will be the information from test 1. Set up your table from 4 to 4.001 that we have on this side, and make sure you've got all your y values, and get that first average rate of change. After you have that, turn the video back on. As we continue, remember that what we had to do before, because the next thing we want to do in this cell, in cell D17, is I want to check the average rate of change between 4.1 and 4. I don't want to do it from 4.5 to 4, or from 4.1 to 4.5. I want to do it between the skipped value, because if I were to drag this down, notice that it did it between 4.1 and 4.5. That's not what I wanted. So I'm going to erase that. And we're going to go back to this one and help it set it up so that I can drag it down instead of having to retype in every cell. Remember what we did before was to anchor the one that was used over and over again. In that case it was at 40 feet. This one is at 4 seconds. So I want the 4 and the 12.160 to be used every time. So in that cell I'm going to go to the 12.160, which is the green cell, and anchor it with F4 or type in your $signs. The other one I want to use is the 4 over and over again, so I'll use the dark red cell, F4. Double click it and check it again. See that both the height for 4 seconds and the actual 4-second cell both have $signs in them. And then we'll drag that down